Hey everyone, I'm Hujuana and this is, once again, Space Doc. Today we are continuing the loosey-goosey series on spacecraft components, this time focusing on weapons, specifically those that use kinetic energy to do damage. Energy weapons and missiles will get their own videos in the future, so subscribe now to be notified when those are released. But first, kinetics. They are very simple, essentially being just objects that go fast to do damage to their target. But as travel speeds in space are inherently high velocity, at least if you're being realistic, you can think of it in terms of relative velocity between the projectile and the target, so you don't even need to fire the bullet. You can just drop them off the side of your ship and let orbital mechanics do the rest. Generally speaking, kinetic weapons are more going to be of the gun variety than the dropping a rock variety, and those have recoil. I'm going to talk more about this later, but it is an important thing to consider when making a kinetic weapon. Another important thing is just how do you want your weapon to do damage. There's a whole scale of damage potential based on how well the projectile transfers its kinetic energy to the target, if that is even the intended goal. This transfer depends on the relative velocity between the target and projectile, the mass of the projectile, and what exactly it hits. Something large hitting something solid at a sort of slow to middling speed will very efficiently transfer its energy, but something small and going very, very fast is more likely to poke pinholes through key systems that don't react well to such a poking. Then there's the possibility that maybe you don't want to even hit your target, as merely the threat of being hit forces them to maneuver to somewhere more advantageous to yourself. Sort of like suppressive fire in space. If the setting is on the harder end of sci-fi, this tactic could also be used to run the target's propellant supplies down while they dodge incoming fire. Out of all weapons, kinetics are definitely the easiest one you can avoid being hit by, as they have the shortest range against a mobile target. This is because they're on the slower end of weapons along with missiles, but unlike missiles, kinetics are generally unguided. There's a complex relationship between the velocity of your weapon, the size of the target, the acceleration of your target, and the distance to your target. The probability of a successful hit increases as distance goes down and weapon velocity goes up, and eventually you reach a point where you will always hit, because the time it takes your shot to travel is too low for the target to move out of the way. Hammerlock in The Expanse is a related concept but applies to missiles instead. Just as a fun note, did you realise that weapons firing backwards when moving have an increased effective range compared to firing forwards? This is easiest to think about in the context of point defense weapons. Shots fired forward will travel less far away from the gun than those fired backwards in the same amount of time. The change in range depends highly on the rate of acceleration, but it's still there. When fractions of a second matter, such as with PDCs defending against a whole bunch of incoming missiles, that time can mean the difference between life and death. That covers the basics of what a kinetic weapon even is, so let's dive into the three main types, starting with the lowest tech option, chemical kinetic. These are your standard gun, wherein a solid chemical propellant is ignited, which rapidly expands into a gas and pushes the projectile down a barrel. These have been around for centuries and aren't going anywhere soon, as they are just too damn convenient. They are on the lower velocity end of the kinetic weapons scale, which means they have the shortest effective range, but are by far the more technologically simple and most accessible option. Chemical kinetics are a very, very solidly proven technology that can scale up and down and side to side. To put some numbers onto their velocity, the APFS-DS rounds fired from modern tanks hit 1700 to 1800 meters per second. These may seem pretty quick, but think in terms of scale in space. If one of those tank rounds is fired at a spaceship 100 kilometers away, it will see it near instantly and have nearly a minute to maneuver out of the way. So not really all that fast in spaceship scales, but technologies such as electrothermal chemical ignition or liquid propellants can push those velocities higher. There are other options though. Light gas guns have been used for years for scientific research into hypervelocity impacts of up to 7,000 meters per second. These work by having a captive gun that pushes a piston, which then compresses a gas down into a thinner barrel where the actual projectile is. These things are used for orbital debris strike testing, but I'm not sure if they're viable for weaponization, as they're pretty lengthy and need both an explosive charge and gas to fire. A simpler but related concept is combustion light gas guns, which have been explored for use as weapons, with a demonstrated velocity of 4,000 meters per second, but faced a number of technical challenges which put a halt to development. As we can see, getting chemical kinetics up to higher speeds is difficult, so if we want better range, we need to turn to electromagnetic kinetic weapons to fulfill our needs. The first type we are looking at is coil guns, also known as Gauss guns. As the name implies, coil guns are full of conductive coils that act as electromagnets. When fired, huge amounts of current get dumped into the coils, which go off one by one in sequence and pull the projectile down the middle of the barrel. The timing required here has to be extremely precise, as the coils need to turn off as the projectile passes them to avoid slowing it down again. This complexity is why the Frontier Union militia in the Sojourn typically only uses coil guns they inherited or captured from the Centrum Defense Force, as the Union doesn't have the technical base to easily produce and maintain them. Instead, they prefer to rely on railguns, but we'll talk about those in a minute. You can learn more about Union ships in the Florencia class breakdown over on our partner channel for the Sojourn using the clicky on the right. Coil guns can reach much higher velocities compared to standard chemical kinetics, as you can push a ton of electrical energy through them, but there's the added complication of generating and storing that energy ready for it to be used. That's fine if you're in a large spacecraft with a fusion reactor, but for small arms where hypervelocity isn't necessarily needed, the convenience of chemical rounds being all in one is hard to beat. There are other downsides to coil guns besides the complicated efforts of getting the timing right, but those are based on technical physics terms like magnetic saturation that I don't really understand that well, so won't even try to explain. There's also another kind of coil gun that uses superconductors to make its coils. These are called quench guns, and that's just the most awesome sounding thing ever. More quench guns in sci-fi, please. But coil guns are complicated. What if we want a hypervelocity gun but a bit simpler? That is where the railgun comes in. These are very simple. You have two rails and a projectile that crosses between them. When you dump an exceedingly high amount of current through this system, a magnetic field is created that is at right angles to the rails, forcing the projectile out. No fancy timing is necessary, just sheer power that exploits the Lorentz force. The problem is, all that power creates a lot of waste heat, as well as electrical arcs between the rails and projectile, eroding the rails and reducing their lifetime with every single shot fired. So while they are less technically complicated than coil guns, they have materials science issues instead. There's also a pet peeve of mine to do with railguns. Something that happens way too often with the depictions of them is that they have to visibly show that there are rails. Ooh, we have a gun that's different in sci-fi, ooh, let's have a gap. I dislike this, as well, it's become a bit of a tired trope, and that it makes no sense. One part of the physics of railguns that has to be considered is that just as the projectile gets pushed down the rails also want to push away from each other. So you need bracing along their lengths to stop that happening, otherwise you end up with two disconnected rails and not much of a gun. Another common misconception is that railguns somehow don't have recoil. I'm not entirely sure where this idea comes from though, potentially from the incorrect idea that chemical gun recoil comes from the gases pushing the weapon back, rather than from the projectile via Newton's third law. It doesn't matter how the projectile is accelerated, just the fact that it is accelerated means the gun goes the opposite way. This means that guns and rocket engines are basically the same thing, but just optimized for different outcomes. One makes use of the recoil, the other makes use of the projectile. If you don't want gun recoil affecting your spacecraft, you have to cancel it out by firing something the opposite way. This could simply be a burst from your maneuvering thrusters, or do what the Expanse did, where PDCs all have little rockets on the back of them to counteract recoil, and even the Rosie's railgun is tied to its main engine. Another thing the Rosie's railgun does, and Expanse railguns in general, is have this purple gas appear when they fire, almost like a chemical kinetic weapon, though rather than pushing the projectile with it, that gas is instead used as a sort of barrel extension. It's purple because it's hydrogen plasma, through which the current from the rails is conducted through, increasing the energy transferred to the projectile after it has left the gun. Having a longer barrel that gives the round more energy is advantageous for all kinetic weapons, but there's a fine balancing act that needs to take place. The trade-offs are that it's harder to move a longer barrel around to aim, and also harder to keep it straight and not like a big wobbly noodle, so the Expanse method for extending railguns is a really neat little idea. The tech from other settings can also be used to juice the power of kinetic weapons even more, the most obvious example to me being Mass Effect's Mass Effect, which affects mass. The weapons there are standard electromagnetic accelerators, but with the projectile's mass being lowered while it's in the gun, allowing it to be accelerated to ludicrously high speeds. Unless it's Mass Effect 1's ending cutscenes, where Alliance dreadnoughts shoot weird slow energy balls at Geth. Not sure what's going on there. Another thing you could do is to combine chemical and electromagnetic, using a chemical first stage and then boosting it with rails. It may be possible to do this with coils, but it's hard enough getting core gun timing right without the variable of an already moving projectile. We've already talked about some of the downsides of kinetics, but all of them share one that's a pretty big deal out there in vacuum: heat dispersion. Railguns probably have it the worst due to the extreme amounts of power required, but coils are going to heat up too, and we already know chemical kinetics get hot barrels. All this heat has to go somewhere, as there's no air cooling to passively keep heat under control, but radiating it out into space is a long, slow process. You'd need some special considerations put in to keep these weapons cool if they're used over long periods of time, such as running coolant around them, which is taken to dedicated radiators. Well, you don't need to do that if your setting doesn't particularly care about that level of realism, but it should, because radiators are cool, or hot. As we can see, there's plenty of options for kinetic weaponry, with lots of pros and cons for each type, leading to different use cases for each, from point defense to spinal-mounted artillery. Even the scale of kinetic weapons can change dramatically, from dropping asteroids to shaving off tiny little flecks of metal. Throw in spicy extras with setting-dependent technology, or even adding different shell types, rather than purely relying on kinetic energy, and you can add a ton of flavor to a setting, or even to factions within that setting. Have fun with it, but please do try to keep it all somewhat technologically self-consistent.
What do you hear?
Nothing but the rain!
Thank you for watching, and if you wish to support the channel more directly, you can do so by becoming a channel member or through Patreon, like all these fantastic people on screen right now. Thanks again, and I'll see you next time.